Okay, this is 5.6a of geometry. So we have a property here called the comparison property of inequality. And it says if a equals b plus c and c is greater than 0, then a is greater than b. So let's try an example here. Let's say 11. 11 is equal to, well, 6 plus 5 is 11. So if I look at that as a equals b plus c, I get 11 is a, 6 is b, and 5 is my c. And 5 is greater than 0, so I'm okay. It says then a is greater than b, so then 11 is greater than 6. Is that true? Yeah. And if I switch it up and instead of saying 6 plus 5, I do 5 plus 6. A is greater than b gives me 11 is greater than 5. Is that true? Yeah. Whenever I add two things, it makes them bigger, right? So whatever number they equal is going to be bigger than each of the numbers. If I do 26, 26 is equal to 25 plus 1. And 26 is greater than 25. Let's make that a better symbol. 26 is greater than 25, and 26 is greater than 1. I could do 25.999999999 plus 0.01110000001, and 26 is still bigger than 25.9999999. When we add two numbers together, their answer is always going to be the biggest. So we use that here. So this angle out here is an exterior angle, remember? And these two blue ones are remote interior angles. And if you think back to our triangle exterior angle theorem, I know that the measure of angle 1, my exterior angle, is equal to the measure of angle 2 plus the measure of angle 3. We add the two remote interior angles, and that equals my exterior angle. So if we use our property there, a equals b plus c, I get that a is greater than b. So the measure of angle 1 is greater than the measure of angle 2. And if I switch how I'm writing this and I make this as the measure of angle 3 plus the measure of angle 2, just switch the order, then I get that angle 1 is greater than angle 3. So we'll look at their problem and we'll look at our problem here. So they want to know why is the measure of angle 2 greater than the measure of angle 3. So the only thing I can use is the theorem that we just wrote down. So I need to get I need to get angle 2 as an exterior angle, and I need to get angle 3 as an interior angle. Well, this here is not an exterior angle right now. But if I look at this triangle here, it has two sides congruent. That is an isosceles triangle. And that means if the legs are congruent, my base angles are congruent. So this angle down here is 2. That means that this is also angle 2. They're the same, they're congruent. Now if I look at this triangle, angle 2 is an exterior angle, and angle 3 is an interior. So then using that theorem, the corollary to the triangle exterior angle theorem, I get that the measure of angle 2 is greater than the measure of angle 3. And let's try our got it problem. So our got it problem wants to know why is the measure of angle 5 greater than the measure of angle C. Whoops, not 6, C. So angle C is down there. I need to get angle 5 as an exterior angle, and I need to get angle C as an interior angle. So if I look at this triangle, angle 5 is an exterior angle, and angle C is an interior angle. So I look at triangle ADC, and then use the corollary to the triangle exterior angle theorem. Alrighty, another theorem. Theorem 510. If xz, that red side, is greater than xy, that blue side, then the red angle, angle y, is greater than the blue angle, angle z. This theorem, along with our other theorem that we're going to do, the general situation for both of them is that the biggest angle, I'll write it out, hopefully not too sloppy. Biggest angle is across from the biggest side. And the same can be said about the smallest angle is across from the smallest side. And the medium angle is across from the medium side. So, we're going to look at our problem down here. It says, suppose the landscape architect wants to place a drinking fountain at the corner with the second largest angle. When we're looking at a triangle, it has 3 angles. The second largest is going to be our middle angle, right? We'll have a biggest angle and we'll have a little angle, the littlest angle, and then we have our middle angle. So, our biggest angle is going to be across from our biggest side. So this angle right here is my biggest angle. And my littlest side is this 105. So my littlest angle is across from it. That's my littlest or smallest, whatever you want to call it. 120 is my medium side. So this is my medium angle. Oh, you can't read that there. Medium. So they're going to put a drinking fountain there. Draw a little drinking fountain in. So where Hollingsworth Road and MLK Boulevard meet up, that's where we're going to put our drinking fountain. So here's the other theorem I was talking about. This one says the same thing, that biggest angle is across from the biggest side. This just starts with the angles. So if angle A, the red angle, is bigger than angle B, the blue angle, then the red side, BC, is greater than the blue side, AC. So, let's just do our got it problem down here. So I'm told that the measure of angle S is 24. And the measure of angle O is 130. And they want to know which side is the smallest side, or the shortest side. But to be able to do that, I need all 3 angles. So I can find that third angle. I'll call it angle X right now, because I know that they need to add up to 180. 24 plus 130 plus X needs to equal 180. So that's 154 plus X equals 180, and I'll subtract 154 from both sides, and I get X equals 26. So 26. So then my smallest angle is 24, angle S. So the smallest side must be OX. Smallest. And my biggest angle is angle O, 130. So this must be my biggest side, SX, because it's across from it. And then angle X, the 26, is my medium angle, so this is my medium side. SO. There's your homework.